Hey everyone, awesome lesson today. It's Friday, which is awesome as well. Today, we're going to be talking about inequalities, one of the most confusing things in all of the math world because I know it's just so confusing for no reason. I'm going to try to clear up that confusion today. That's my goal. You got this. First thing I want to do, I want to talk about what an inequality is. Basically, that's a math statement that includes some symbols like these. These might look familiar. The way we can say these are, we got greater than, less than, greater than or equal to, less than or equal to, or not equal to. I know there's some confusion with these. Every time you see them, you're like, I don't know if that's less than, I don't know if that's greater than. I'm going to clear that all up right now. Everyone knows how to draw an L. I'm drawing an L right here. There's my L. Now, does this L look more like this one or like this one? Well, it's not flipped this way. It's flipped this way. L stands for less than. So here's what we're going to do. This one looks like an L. This one looks like an L. The one that looks like an L is less than. That's my tip for you. Less than. Less than looks like the L. That means that greater than has to go the opposite way. So anytime you look at it, make that L with your fingers. Make that L think, is this one less than or is this one greater than? Let that help you out. Now the one that has the line underneath, greater than or equal to, we'll talk about that in a second. And this one would be less than or equal to. This little tool I put in this corner here might be helpful for you to put in your notes, especially on tests and quizzes. I think that'll be helpful. Today we're not going to be actually doing any problems with this, but all that means is an equal sign, and then you put a little X through it, meaning not equal to. All right, we got greater than or equal to, less than or equal to. We're using our L's to remember which one is which. We're going to crush today's lesson. Here we go. All right, so we have our inequalities. All that means is a math statement containing greater than, less than, greater than or equal to, less than or equal to, or not equal to. So there are solutions for these. We've been talking about solutions the past few days. They're ways that make a problem true. So a solution for inequality is any number that makes an inequality true. Here's my example. 7 is a solution of x is, what is this? Does it look like an L? Nope, it goes the other way. So I know this is greater than. And I see a line underneath, so I know it's greater than or equal to. 7 is a solution of x is greater than or equal to 3, because what we do, we plug in 7 for x. Check it out. 7 is greater than or equal to 3. Is that true? Is 7 greater than 3? Yes, it is. 7 is a bigger number than 3. This is true. This is a solution. We're going to be working on that today. I got one more thing that I want to make sure you get in your notes, and it is this right here. This, I think, is another super confusing idea for students. When we are using our timelines here, we'll get to it in a second. I want you to put this little diagram down here in your notes. An open dot on our timelines means less than or greater than or less than. The open dot saying it doesn't include this number. Here's the timeline, or here's the number line, but not this number. This is just where the dot is. A closed dot means greater than or equal to or less than or equal to, saying, oh, it includes me too. I'm here. I count. The open dot is saying, nope, I'm not there. It's empty. The closed dot says, me too. I count too. We'll get to that in a second here. That'll make more sense. We're going to put all these ideas together. So anytime that you see this symbol right here, you can think greater than or equal to or less than or equal to. What that's saying is it doesn't only include that number, but everything above it. You'll get plenty of examples with that here if you're confused about that right now. So we're going to draw some diagrams here. We're going to draw on our number lines. I'm looking at this first one. I see y is that an L or no? Yes, it is an L. So I see y is less than 3. So what I'm going to do is I'm going to find 3 on my number line. I'm using my tool. Is this going to be an open dot or a closed dot? Well, it's not equal to. It doesn't include 3. It doesn't say y is less than or equal to 3. So it's going to be an open dot here. Use that diagram if you need to. Open dot right there. Y is less than 3. So if y is less than 3, is my arrow going to go bigger or smaller? Well, we know y is less than 3, so it has to point to all of the things that are smaller than 3. We know y is less than 3. It could be any of these numbers less than 3. Can it be 3? No, it cannot, because it's not equal to. It's not y is less than or equal to 3. That's why we have this open dot here, because it can't be 3. 3 is not included. So that's what your diagram would look like for that first one here. Move on to our second one. We've got x. Is that greater than or less than? Think about it for a second in your head. Make that L if you need to. I'm making my L. Doesn't go the same way, so I know this is greater than. X is greater than -1. So what I'm going to do right away is I'm going to put that open dot on -1 because I see the equal sign is not there. X is greater than -1. I'm thinking greater than means it's bigger than. Greater than equals bigger than. I can even write that over here. Greater than equals bigger. Greater equals bigger. Less equals smaller. So I'm thinking x is greater than -1. I'm thinking it's got to be bigger. My arrow's going this way. I leave that open dot because we don't have an equal to sign. We're going to move on to this bottom one here. We have a is, what does that mean? Use your helpful tool up here that we have if you need to. But I'm going to look at that. I'm going to make my L. Oh, it matches. It moves in the same direction. A is less than, but not just less than. I see that line underneath. Or equal to. A is less than or equal to -2. I'm going to put this dot on -2. Do I fill it in? Yes, I do. I do fill it in because it is less than or equal to. It's saying me too. Include me. It could maybe be -2. Okay. A is less than or equal to -2. If I'm thinking less than here, so if it's less than, it's going to be smaller than -2, and that means I have to go this way. I have to go deeper into the negatives. It could be anything less than or equal to -2, including -2. Okay, awesome. We got our first closed dot. Let's go back up here. We got Z is, look at that, make my L. Yep, it matches. Z is less than -2. So before we had A is less than or equal to -2. Now we just have Z is less than 2. So you're probably thinking, oh, it's going to look pretty similar, but this time our dot stays open because it can't be -2 because we know it's less than -2. So it can't be -2, but it can be less than. All right, last one of these examples. We've got -6 is, oh, look how many less than examples I have put in here. Put a lot in. Less than or equal to, I see that line underneath. I hear equal to, I instantly know that this is going to be my closed dot. So I find -6 on there and make that closed dot. Pull my L, less than. And what am I going to do here? If I am less than -6, that means I'm not bigger than -6. I am smaller. I'm smaller. Now, when you're making these number lines for yourself, always remember to make positive go this way right here, negatives go this way. Every time. You go positive that way, negative that way. Awesome. Uh-oh. Look at this. They gave us our number lines already, but they did not give us our inequalities. So we're going to practice writing them. Okay. Well, I see 0. 0 is our mark here. That's where our dot is sitting. So I know that's going to be part of it. 0. Okay. Right away I'm thinking, closed dot. or open dot here. We have open dot. That means I look back. Open dot, it's not going to be equal to, it's just going to be less than or greater than. Okay. It's moving up. It's getting bigger. It's getting bigger. It's going from 0 upward. That means it's going to be greater than. So here's where you can get some confusion. We want to write this so that x, we decide is greater than, we're always putting our variable at the front here. You know what? I think I just realized I made a mistake. I'm going to go back to that in a second because I don't want to confuse you. But we're going to finish up this one. So x is greater than 0. I know I have to make it this way, make it greater than. We got that open dot. X is greater than 0. Perfect. Now I'm going to go back because I realize I made a mistake. Maybe some of you caught my mistake. But if you notice, we have our variable in front on all of these except for one, this very last one. So I read this out loud as -6 is less than or equal to g. So if I think about this, g, -6 is less than g. So g is anything above 6. I did that the wrong way. Here's another tip for you. That's my apologies. If you're confused on that one, just scratch that. I don't want to confuse you any more than I already did. So if that part confuses you, just drop everything I talked about that one. Forget about it. But here's how this works. Our inequality signs, if you want to think about it as a mouth, that's another awesome way to think about it. It always eats the bigger number. It wants to eat more. It's going to eat what's bigger. It wants to eat more. So if it's pointing this way, we know that the bigger number is g. It's eating g. I know it's kind of childish. It wants to eat more though, so it's going to be bigger. Don't let that one confuse you. My mistake. My apologies. Moving back to this. So we figured out that if I read this out loud, x is greater than 0. I look at this, I have 0. Moving greater than, checks out. Next one, we're going to do, let's do w this time. W. I see we're moving downward. So I know w is moving downward. W is less than. It's getting smaller. W is less than what? It's marked on -1. Let's put a -1 there. W is less than -1, but I'm not done yet because I have a closed dot here. That means it's going to be less than or equal to. W could potentially be -1. W is less than or equal to -1. I see it moving downward. Again, put that variable in front when you're writing them for yourselves. Don't let it trick you. All right, I got one more example, then we'll let you get going here. Here's a little picture I drew. Here's my car if you like it, and there's my monster truck. So I have right inequality with the number line. This says no cars. Why did I write of? No cars 8 feet tall. I think I meant to write over. No cars over 8 feet tall. Perfect. Okay. So I'm going to make my number line here. There's some music playing in the background now here. Someone's jamming out in the hallways. I'm going to make my number line here. We'll put 8 right here. 9, 10, 7, 6, 3, 2, 1. All right, I know that we're sitting at 8 here. No cars over 8 feet tall. So for now, I'm going to make it an open dot. We might have to change it later. And we know that x cannot be greater than 6 feet tall. No cars over 6 feet tall are allowed. That means everything's got to be below. It's all got to be this way. I'm thinking that way. That's less than. So x is going to be less than. I make that L 8. Now it says no cars over 8 feet tall. So this is where you could maybe be like, maybe you could be equal to 8 feet tall. I'm not going to really say that right now. I'm going to pretend that you can't beat 8 feet tall. No cars No cars, let's change it up. No cars 8 feet tall or over. So you got to be a car under 8 feet tall in order to get in. The monster truck's over 8 feet tall, it can't get in. This car is under 8 feet tall, it can get in. Take a look at these examples. As you're doing your homework, pull this back up. Make sure you get this jotted down. Make sure you get this jotted down. I apologize once again for this one. Don't let me confuse you on that. I always like to start with the variable and the other way. I missed it on that one. All right, there's our inequalities and graphs. Nice work. Let's crush them.